Dear students, look at all this stuff. I was going on teaching and the mobile has got cut because the camera started working because of a message. Okay, so I have shot around 5 minutes of video. So let me erase this whole stuff which I taught already, thinking everything is getting properly videographed. Okay, yeah, once again let me continue from where I left. Okay, it's very frustrating. Yeah, we are all learning. We are also new to this kind of teaching in online and making shooting videos. Okay, it's fine. We all learn from our experience, and today this is the experience again. Yeah, again let me continue from where I left the previous video. Okay, now I was telling there that there is a point here A, this is VA, there is another point here which is VB. Now let me think there is a piece of wire, right? Now these are the 2 points. The potential at this point is VA and the potential at this point is VB. So VB minus VA is the potential difference. Now why do you need this difference? If there is no difference, the charge will not flow. Now what is the charge which is flowing? Electrons. But we know about electrons only in 1897, discovered by J.J. Thomson. Okay, till then people were thinking atom is, you cannot break the atom with a positive nucleus, with a neutron and the electron. So till 1897, people thought that positive charges are flowing. Okay, so that is positive charge flowing is called conventional current. It's called conventional current. Okay, we respect them, so we keep that. Okay, now when you say this, when the current will flow, when anything will flow. For example, I got a tube here, right, and this is at the same height from the ground, let us say. What will happen if I allow water to flow through it? Will it flow? The water will not flow. Water, when it will flow? When I just tilt this tube like this. When I tilt it like this, it will flow. Why is it flowing? That is the difference in the height. Okay, there is a difference in the height. Because of that, it is flowing. Temperature, there should be a temperature difference. From hot temperature, it will go to the cold temperature. Heat will flow from hot to cold. The water will flow from higher level to lower level. What is pulling it down? The gravity is pulling it down. Like that, electricity in a wire, you have charges are there, ions are there, free electrons are there, right? How the electrons will flow? There should be a difference in potential between these 2 points. Now how can I give for an ordinary wire a difference in potential? That means I have to connect a source. Okay, let me connect a source here. Let me take a battery cell. Okay, this is the cell. In the cell, you know, inside there is a carbon rod is there, and this is the positive terminal, zinc cup is there, and it is a negative terminal. Okay, now when I connect the positive, right, positive of the terminal to here and negative of the terminal to the point here. Okay, this does not have positive and negative. Wire does not have positive and negative. I connect the positive terminal of the cell to this point A and negative to the point B. Then what will happen? If you take this is a 1.5 volt cell, what does this mean? It means that the higher this point is 1.5 plus 1.5 and this is minus 1.5. So there is a difference in potential. If there is a difference in potential, then only current will flow. So in conventional current, they thought positive charge is flowing, right? So they said that from positive of the cell and it comes like this and comes back to the negative of the terminal of the cell. And this is called a closed circuit. right? If there is a break in that, current will not flow. That's called an open circuit. Now this is called a closed circuit. So now there is a difference in potential, and that is why there is a flow of current. Current here now we define is due to the flow of electrons. Now how does the electrons flow? It flows, electrons are in the negative terminal, they come from negative, so I will put it in opposite like this, and it will go like this, the electrons will flow like this, right, opposite direction, and it will come back, and it will come back to positive. Remember, when you draw in a circuit, then you have to write conventional current direction, positive to negative, but in the general you should understand electrons are flowing, that is from negative to positive. So you may get a doubt, how the electrons are coming here? Because of chemicals. Let me erase this now and let me draw a cell for you. First and foremost, we will draw a cell, and then from that cell we will proceed further. Okay, let me erase the board neatly. Yeah. Fine. See, I am going to take a cell, big cell like this. You got Novino or Eveready. Take a carbon rod. Surrounding the carbon rod, there is a chemical, manganese dioxide, MnO2. And inside the cell, there are other chemicals are there, like ammonium, NH4Cl, and you are having NH4Cl and zinc chlorides, zinc chloride. You have all these chemicals are packed inside, right? But in a dry cell, they are all in the form of a paste actually. Okay, so NH4Cl will become NH4 plus, Cl minus, zinc 2 plus, chlorine 2Cl minus, okay, and also water H2O, right, H2H plus, O2 minus, all these ions are there. When the ions are breaking, the free electrons will come out, and that free electrons will come and get collected near the negative terminal. The zinc cup I have taken will act as a negative terminal, and the carbon rod will behave as a positive terminal. More electrons are there. That means from where did they come? They come from the chemical only. So we can say this part is more positive and this part is more negative. So in olden days they said positive is higher potential and negative is lower potential. So how the electrons flow? They flow from higher potential to lower potential. Let me connect this to a bulb with the help of a wire. Let me connect it to a bulb like this, right? Now, the current is going to flow. When I say current is flowing, conventional current, positive to negative, positive to, this is I is the current, and it will come back, okay? And between these 2 points, let us take 2 points in the circuit, okay? And this is, let us say VA, and this is VB. Now, what is the potential difference between these 2 points? How can I measure the potential difference? I can use a voltmeter and connect it here. I will be able to measure the potential difference. Here the meter is called voltmeter. Now when I connect the voltmeter and it is measuring the voltage potential difference, it will tell, see, one is positive 3 volt, this point is, right, and another is minus, right, 3 volt. So 3 minus of minus 3, that is equal to 6 volt. Yeah, so that is how you are measuring. I am just giving you an example, right? Don't take it exactly, it's 1.5 I said. So just I am telling you, there ought to be a difference in potential, then only current will flow. As I said, there should be a difference in temperature for heat to flow, difference in height for the water to flow or a body to roll, right? There should be a difference in potential. Okay, so that is called potential difference. It is also often referred to as voltage. Terminal PD is also called voltage in common term. Voltage is less, voltage is more, right? So remember, Potential is a concept, definition. Potential difference makes the electrons to flow. Sir, now we come across one more thing called EMF with the symbol epsilon. Now what is this EMF? You know, already we are confused with potential and potential difference. Now there is something called EMF. Don't worry. EMF is electromotive force, but this is not a force actually. It is force multiplied by displacement. That is its work, or it is nothing but energy, right? And what is EMF? Now look at carefully. This bulb requires 1.5 volt to operate. Without 1.5 volt, you know, sometime when current is less, the bulb will become dim. The fan will rotate slower, right? And it cannot operate less than that particular value properly, right? Too much less voltage, it will not work at all. So now which is supplying this energy? That is supplied by the cell. But inside cell chemicals are there. What will happen to these chemicals? The chemicals, the ions are moving. They are hitting with each other. Naturally what will happen? Inside there will be something called friction. Friction, anything moves will have friction. And that friction we call it as internal resistance. What is it called? Internal resistance. Okay, internal resistance will be of small value, not a big value, small r. And this bulb is giving, this is called capital R. Okay, now because of that also, inside positive, negative, like this, you can imagine like this current. So naturally there will be a friction, and that is called internal resistance. You have to account for internal resistance also, and that is what you call it as EMF. I am going to now write the relation between all these factors. Yes, then you will understand much better. Much better. Okay, let me just try now. So remember the facts. EMF, internal resistance, capital R is external resistance, right? And V here is potential difference. I is the current. How will I measure the current? I can measure by connecting an ammeter. This is a ammeter. Okay. Now what is the connection between this? This is the source which is giving, you know, epsilon is giving for what? According to Ohm's law. What Ohm's law says? Ohm's law says that V is equal to R into I. Therefore, epsilon is equal to. Step by step we will do. There internal current is flowing here also, same current is flowing through the internal resistance, so I into R, plus external also I into R, add these two together, this is the total value. R EMF is equal to IR, you keep it as it is, plus what is V into R? External resistance, potential difference according to Ohm's law. So we can say V is equal to epsilon minus I into R. So this is the main formula. Okay. Now what is EMF? EMF is when no current is flowing through, right? The circuit is open. Then what you see here, that will be called EMF. Because when you want 1.5, the company, the Eveready company or Novino company will set this for some account for internal resistance also. Okay, and that is why the EMF will be higher than the potential difference. 1.8 minus, I want 1.5, so how much it will be? 0.3. Therefore 1.5 is equal to 1.5. That means what is the potential difference I want to operating voltage, that is 1.5, this cell will give. If I keep 1.5, what will happen? I will get only 1.2 because there will be a loss inside. Yeah, so that is why it should have more. So the EMF should be greater than the potential difference so that we can account for the loss due to the internal resistance. I hope you understand. You try yourself and patiently think, understand, and then plan and do it. And still if you have any doubts, just message me as Manas did. I thank Monas for having asked me the question and made me think more better, right? And I have tried to answer. Still you have doubt, you are always welcome to ask me questions. Yes, a good question will lead you to a good answer. So ask me questions. Thank you.